Problem 1, Tactics Box 1.4, adding vectors. We're going to use the tip-to-tail method to add vectors B to vectors A. Well, let's see, add vectors A to A plus B. So here we go, we're going to use the tip-to-tail method. So we're going to grab B, and what we do is we slide it without changing its direction or magnitude, and I can't do that anyway. And what we're going to do is we're going to take the tail of B and put it right to the tip of A. And so this graphical method of adding vectors is called tip to tail. I would call it tail to tip, but nobody asked me. Now, the resultant vector, the sum of vector A plus B, is actually going to be a vector that goes from the tail of A to the tip of B. So we're going to basically get that vector, and now we need to draw it. So we're going to start at the tail of A, and we're going to draw it to the tip of B. And so this is the vector sum. So if this was a force vector, this would be equal to the net force. They're the sum of these two forces. Let's see if it's correct. Yay! Part B, we're supposed to determine the vector sum. And R is typically the symbol used for the vector sum. It's the resultant. That's where the R comes from. Resultant. That just means, hey, the vector sum of vector C plus vector D. And so it says make sure to move D. So we're going to move D. And so we take D and we move it so that its tail is at the tip of C. And then to get the resultant, the vector sum, we go back to the tail of C and we draw our arrow until it touches the tip of D. And this is the vector sum of these two vectors. Let's see if I'm correct. Yay! Vector addition ranking task. You are given vectors A through vector F, and you're asked in part A, you're asked to do some vector addition and then tell us which ones are the biggest, longest, greatest magnitude vectors and which one, and the rank order them from biggest to smallest. So what I've done here is made a little sketch of just using the tip to tail method to add all 6 vectors, A plus B. You take A, put B, tip to tail, and the resultant, the vector sum, is you start from the tail of A and you go to the tip of B. And it's in it for all of these. And I changed the scale and the color isn't great. So what I've done is, let's just take all these sums and put them really getting ready to answer the next question. And you can see them, they're a little better here. So I just made a little scale model, and these are just the sums. So you can see which one is the longest. Vector A plus vector C is the longest. Then it's a tie between A plus vector D. And then you can see this one, different direction, but the same length. That's the key thing. Magnitude is independent of direction. So there's A plus B. So it's a tie for second between those two. Then it's a tie for third between D and vectors F plus vector C. And then poor little vector A plus E is only essentially one block long on the original diagram. Okay, that's the first one. The next one is to rank the vector sums in order of direction, and we're not going to be this formal about it later when we get into this stuff in chapter 3 and chapter 4. But basically the official rule is start at the x-axis and go around in counterclockwise, and you're going to measure. So it would be 0 here, 90 here, 180 here, 270 here, and all the way to 360. So I just did that here, and vector A plus B is way down here in the 4th quadrant. So that's, 315. Then comes D and F are at 90. That's a tie for second. Then comes getting, smaller angles. Then the next angle is A plus D. That's 45. That's 3rd place. And then vectors A plus C and vector A plus E are tied at 0. There you go. That is, what problem is this? Vector addition ranking test. Tactics box 3.1, subtracting vectors. Subtracting vectors is essentially adding two vectors together, except instead of a plus b, where you would add a plus b, tip to tail, now you're going to add a plus negative b. So we're just going to flip the b vector around 180 degrees and then use that. So that's what the instructions say. So let's apply that to part A, where we're basically going to say, okay, vector C is vector A minus vector B. So the first thing you want to do is go get a negative vector B, but it doesn't just show up, you have to make it. So we're going to make it by drawing a vector that's opposite in direction to B, but the same magnitude. So hopefully I'll get close enough to get credit because I'm doing it the right way. There, so now that is our vector negative B, and we're going to take that and we're going to put its tail to the tip of vector A. Now we're going to go get our vector C. Of course, we have to draw it. And just like before, we're going to start at the tail of the first vector and we're going to draw the arrow of the resultant to the tip of the last vector. And then we're going to hope it's right. Yay, it's right. We want to find vector F, which is vector D minus vector E. So I think we're going to kind of do the same thing. What is it again? Vector D minus E. So we need to make a negative E vector. So negative E, and then we're going to need to basically create a vector that's the same magnitude as E, but I don't know, same magnitude but opposite direction. Okay, so there's our negative vector. Now we're going to take it and we're going to put its tail. Oh shoot, I think I changed it. All right, let me trash that guy. Sorry. Yes. Okay. All right, start over. It happens. Okay, draw the negative vector. And then, okay, now we're going to move it. I just couldn't see. My giant hand is kind of getting in the way there. My giant green hand. Okay, pretty close. All right, so same as before. Now our resultant vector, we're going to start at the tail of the very first one and draw it to the tip of the last one. And that's it. Let's see if I got close enough. Yes, it is. All right. Good job.